In this video, I will review multivariable integral calculus in 10 minutes. Multivariable integral problems can be solved via conversion to single variable integral problems. Rule 1. Separate the functions. If you integrate f plus minus g, the result is the integral of f plus minus the integral of g. This applies to double integrals, triple integrals, etc. 2. Separate the variables. If you integrate a product of f of x and g of y, the result is the integral of f of x times the integral of g of y. What about the integral of f of x divided by g of y? The result is the integral of f times the integral of 1 over g. This comes from the product rule. Now I'm going to give you an example to integrate this xy squared minus cosine squared. So first we separate these two functions. Therefore we just need to focus on x times y squared and cosine x separately. And x times y squared is the product of x and y squared. Therefore we can separate this two variables. This double integrals becomes the product of two single integrals. The first integral is the integral of x. The second one is the integral of y squared. And both can be easily solved. How about this one? This one is even simpler. It's just cosine x. We just need to integrate this cosine x and then integrate this dy. What's the result? Over here, the integral of x is 1/2 x squared. The integral of y squared is y to the power of 3 over 3. The integral of cosine x is sine x. The integral of 1 dy is simply just y. And we plug in the lower limits and upper limits. The result is 9 pi squared over 2. Rule 3. When the variables cannot be separated, we just simply integrate with respect to one variable at a time by holding all other variables constant. For example, let's integrate this 1 over x plus 2y. So first, let's hold y constant. Really, you just integrate 1 over x plus a constant. That's the natural logarithm of x plus that constant. So we got this here. We plug in the lower limit and upper limit of x. We got this function here. And then we integrate this function. So we can integrate this two separately. And here's a small trick here. It's a bit more trickier to integrate the logarithm of 2y. So what we do is we have this guy minus ln2 and then this guy minus ln2. Therefore, we just need to integrate the logarithm of y plus 1 and the logarithm of y plus half. The result is simple. The integral of ln x is x times ln x minus x. Therefore, the integral of ln y plus 1 is y plus 1 times ln y plus 1 minus y plus 1. And we plug in lower limit and upper limit. Same here. The integral of the logarithm of y plus half is y plus half times ln y plus half minus y plus half. And we plug in the lower and upper limits. After we plug in all those numbers, the result is 0.38241. Now we can integrate this function in a different order. We can integrate this function with respect to y first. So we swap y and x, and we're going to integrate this function with respect to y first by holding x constant. When x is a constant, we're just evaluating the integral of 1 over 2y plus a constant. So what we need to do is we take this 1/2 outside the integral, and then inside you have just 1 over y plus x over 2. And again, treat x over 2 as a constant. Therefore, the integral is just the logarithm of y plus x over 2. And we plug in the lower limit and upper limit. We got this function here. This is a bit trickier, so we're going to just use this guy plus ln2. We get ln x plus 6. This guy also plus ln2, we get ln x plus. It's a bit easier to integrate this ln x plus 6 and ln x plus 2. What's the result? The integral of ln x plus 6 is simply x plus 6 times ln x plus 6 minus x plus 6. Remember, the integral of ln x is x times ln x minus x. And then we plug in the lower and upper limits. Same here, we get this expression. And then we plug in numbers, we get the same result, 0.38241, 0.38241. So it doesn't matter which order you integrate the function of two variables. How about triple, quadruple integrals? We use the same rules. 1, 2, 3. First, separate the functions. 2, separate the variables. 3, if the variables cannot be separated, simply integrate with respect to one variable at a time by holding all other variables constant.